All right, so now we will continue our learning in reservoir simulation using tNavigator software. And this time we are still in wells data section, and we have completed this section actually by providing the well history table or production history table, perforation history table. All right, these two tables, and then we provide with development strategy. We set the global rules and also the rules for each time step. So we have the time steps, and we don't provide with the VFP, okay, to make the simulation simpler and faster. And the summary of all of those operations are registered here. Operations, for example, the well specification for the 33 wells, and we also have well track or trajectory for all the wells, and also the com.md or the perforation MD. Okay, and all the descriptions like here, well name, upper measured depth coordinate for connection. This is the lower or upper perforation and bottom perforation. This is the type of entered interval, open, and this is the wellbore diameter. And the next operation is comprod or order of well connections. And wconhints or well history, production history, and operating target, well control. Okay, for each time step. So here, April 2014, and this one, May 2014. Okay. By the way, if you want to check again the data, the date data, if we check the table, for example, if I want to check again, day, month, and year. Okay, so it's actually day, month, and year. Okay, so I have 5 dates only. So it's actually 5 January 2014. Okay. All right, so far so good. So after completing this wells data section, now we need to go to cases. Okay, here, this is a very, very important section because now here we will set all of our case. We manage the case here. So here I only have one case, which is called dynamic model. And this is the result. Okay, I only have one case, one scenario. You can also put it that way. If you want to create another case, you can right click, create new model, or you can also right click here in dynamic model. You can create new model, create new child model, duplicate or duplicate to child. You can also add existing result, rename if you want to put some comments, or you can also create forecast from this case. Okay, if I right click here, I only have one create new model. Okay, it's really a new model, so everything can be different from the dynamic model existing here. If I just want to duplicate, then I can right click and click duplicate. But if you want to make it here in the child tree, you can right click and create new child model. So I will have new child model, which means another model, new model, but it is still connected to this bigger case. Okay. But if I want to make duplicate and then just do few modifications. I prefer using duplicate to child. Okay, I will duplicate the case and I will make it inside this big case. Okay, and it is duplicated, so I can just modify some parameters a little bit to give me a sense of what will be the impact when I change some parameters. Okay, let's say I just want to have one case. So here in dynamic model, our case, we have run spec, static, aquifer, fluids, faults, selective writing of results, schedule, and project manager cases. Now we need to define everything that will be used in our simulation. The first one is run spec. As the name implies, it's everything about specifications that we need to set. Okay, this will be the specification for the running. Like here we have main settings, the specification for fluid composition. Okay, this is the description. You can see as per default, we have checked for some descriptions like this one, like run contains dissolved gas in live oil, checked. Run contains gas, if yes, then check. Indicates that the run contains oil, check. Run contains water, check. Okay, you can also open this one if you want to know about that. This is for fluid composition only. For dimension, you can read it, but of course, it is quite tedious. Too many things to read. Okay, that's why tNavigator helps us to set all the required specification by just clicking this one, autofill run spec section. Okay, this will be autofill the everything that is required for our case. So just click and everything is done. Okay, so we can trust the tNavigator have already selected everything that is necessary. If you want to read the messages, click this one, messages. Okay. So if you check this one, the last messages, you see autofill run spec. So autofill run spec have been clicked. Set specify run title. So the title dynamic model, set table dimensions, table dimension, this one, tab dims, number of saturation table only one, maximum number of RS or RV 20, number equation of state regions for reservoir condition 1, number of rock tables 1. All right. Everything has been set after clicking this autofill. So don't worry about that. Okay. If you want to open, you just click. If you want to close the messages, you just click again. Now the static. Here we will select all the static properties that have been imputed that we want to use in our simulation. Okay, we will get that from this current grid. I only have one grid, which is main grid. And now we will click this one, insert new, and I will select all the static properties that is very, very required in my simulation. For basic case, I just need basic grid properties, and I need 5 properties, 5 basic properties, which are porosity. Okay, porosity is a must, and I have grid for porosity, which is this one, poro. So porosity will take the values, the grids from poro grid. Click add, close, and you see I have one. in my case specification. The next one, open again. I need to provide with net to gross, and I have the grid. I call the grid NTG. Click add. And then permeability along X, I have that one, perm X. Add permeability along Y, I have perm Y. Add permeability along Z, perm Z. Add. Okay, so these are 5 basic static properties that need to be imputed and selected in our case. Okay, in order for the simulation to be able to run. Okay, and then aquifers. If you have aquifer that will be involved in your case, then you need to insert the aquifer. But we haven't created any aquifer in our model, so we will skip it. Fluids. Of course, we have fluids. And as you can see here, we have several things to input. First one is relative permeability. I have my relative permeability data, which is this one, relative permeability 1. And I will input this available relative permeability to the table. So how do I do that? I click this one, I click this one, automatic mapping. Okay, so the available relative permeability will be stored in this table. Okay, and then I will do that also for PVT. Click this one, click this one, click this one, auto mapping. Initial condition, equilibration data specification also. Click click this one, automatic mapping. Lastly, raw compressibility. Click this one, automatic mapping. Faults. Again, just like aquifers, if you have faults, you need to select and you need to insert the faults here. But we don't involve any fault in our model. You can check again. You see, we don't have fault here. So in cases, we can skip the fault. And then selective writing of results. I prefer just following the default. This is just writing of results. Either you want to write it this way or that way. If you want to make the results in days or in months or in years, you can set it here. But we will skip it. We will follow the default. Okay, and then schedule. This is very important. Here we have one already, the development strategy. Okay, development strategy that we have created in Wells data section. Okay, this one, development strategy. Okay, so case, this one. Okay, actually we are almost ready to run the history matching, but maybe here we can go to Wells data again, go to strategies. You can click here, verify rules, and you can check the messages, warnings and errors open. Yeah, you can see a lot of warnings there. And as you can see, if we read, warning, cannot find gas rate data for well 13 at this date in table. So actually we don't have gas rate data. So that's the warning, but it's okay. We will run without gas rate data. All right, I will close the messages and the warnings, go back to geometry objects. Okay, at this point, we can click this button, Initialize Dynamic Model. So let's click, and you must save project before continuing. Save project, select result name, result path. I can create new, or I can also replace existing dynamic model, the available case. I will select this one, click OK. All right, and here The model is in initialization, all right? Okay, so the initialization is in progress, but I think, yeah, here the initialization is paused. We can check the warnings. You can see error cannot compute model, error cannot init model by specified list of keywords. Okay, you can see we have several problems here, including oil viscosity. Okay, oil viscosity. We need to modify it, I think. All right. Please consider increasing minimum pore volume value. And this one, keyword oil viscosity can be used only with thermal. So we can check the run spec, check the fluid viscosity. Let's check the grid, no schedule, options, other, ASP, no, oil vis. We need to find this one, oil vis. I think there is no problem here. Also, it is okay. No problem. Fluids, no problem. If we continue the initialization, okay, let's check. Still the same problem. Okay, or maybe we need to correct the PVT, oil viscosity. There is no problem here. Okay, let's analyze this first, and we can also check the messages here. The messages we can check. Warning, unable convert keyword. Yeah, this problem sometimes happen. Okay, so yeah, you need to be familiar with this kind of problem. You need to be patient, and you need to modify a little bit, or maybe you can contact the tNavigator team to help you to solve this kind of problem. But let me solve this for a while. So all right. Okay, so if you go to the message and read again, keyword oil fist can be only used with thermal or E1 temperature options. I think the problem is here. Oil viscosity versus temperature. It is not necessary because in our model, it's not a thermal model. So we will assume isothermal condition, constant temperature. So no use for oil viscosity versus temperature. So let's check whether we can change this condition. Okay. Okay, we will go to the PVT designer again. Okay, and then I will create another PVT. So let's call it fluid. All right, the water we can use the water, and then as per guideline, I will use tNavigator guideline for oil, PVT designer oil, specify the name, and then press the correlation settings. I will do that. Click this one again, oil. Okay, so actually we don't need to check this. Okay, this is only used for thermal model. So settings are table type, leaf oil, and the specific gravity for oil 0.86 and gas 0.72. Use standing correlations. Okay, so all right here, or it can also be 10, starting from 1 bar, and then the maximum 101. Everything will be in standing correlation. temperature 100 Celsius, this will be 0.86, whereas for gas, this is 0.72. Okay, bubble point pressure 60 bars, and then isothermal compressibility, this one. Okay, and then table type live oil. Okay, all right, so far so good. Click OK. Okay, this will be our oil. And then for gas, okay, for gas, 1 to 101, specific gravity of gas is 1 with Z factor of 0.9. Okay. It's 10 from 1 bar. Okay, and then the model is dry gas. We will use Lee et al. For the viscosity and gas formation volume factor will be used standing, temperature 100, specific gravity 1, Z factor 0.9. Okay, I think we can use that. Click OK. All right, so we have water, gas, and oil. And let's check if we have condition for water. All right. So water, we can use the available condition. And then go back to model designer, fluid properties. Okay. So yeah, I think it is good already. Now we can go to the model designer, this one. So instead of this one, the PVT, we will use fluid, this one. Okay, so if you compare for the oil section in PVT, we have oil viscosity versus temperature, which is not necessary and even troublesome. If we go to fluid, oil, we don't have that. So these are the correct fluid model that will be used. So we will use fluid and we will change the case management. So this is the thing that will explain why case management is really important. So we go to fluid, PVT. I will change the PVT here with fluid. Okay. Can I change or I cannot change? So I will save first. Okay, the calculation is paused. We will change this one. We should change this one with the fluid. Okay, so if we use create new model, okay, then later we will, or this one, or instead we will create new model and we call it dynamic model use, like this one. Click OK. All right. I will use this one. And as usual, we will go to the run spec. Okay. And then click run spec. And then we select static, main grid. We will select the properties. Porosity will use poro. And then net to gross use NTG. Okay. And then permeability along X will use perm X. Permeability along Y, use perm Y. Permeability along Z, use perm Z. Okay, close. So we have 5 parameters. No aquifer. Now the fluid, I will use this one, automatic mapping, PVT, use fluid, automatic mapping, and then this one, automatic mapping, row compressibility, automatic mapping. No faults, as per default, schedule, plus I will use development strategy, insert strategy. Okay, this one, project manager, yeah, as per default. Okay, so here I will click initialize. You must save, yes. Okay, I will replace dynamic model. Okay. I hope this okay. Problem again. Maybe because of this. Okay. So I will use this one actually and not this one. Okay, I will solve this one first. This one I can delete, but I cannot delete this one. I will try to solve it first. Okay, so I double click and I will remove this case. Okay, let's see if we can remove. Result is view only. Okay, so I will save and I select this one, and now I will try after I double click here. Hopefully the concentration will be on this case, and then I will try to initialize. And then I will change the path instead, dynamic model that will, or yeah, I will replace this one. Okay. Okay. And then, yeah, it's okay. Everything fine. Schedule okay. Initialize. Now we have another problem. Grid is not specified. Which grid? This one. Parameter IKW list base is not specified already. Fluid. Row compressibility. Building current model. Calculation cannot be started. IKW list base is not specified. I think we have performed the run spec, right? Okay, too many errors. I think I will try to clean some problems first again. All right. Okay, so first I start to close the model. Okay, and then open again. And now you see the active case is now this one, dynamic model use with correct fluid already mapped. And now this one, I will try to remove this model. Okay, because the second or the original model use wrong PVT. So here I will remove. Okay, or instead of removing this one, I will just make sure that this one will be the active one. If you want to make this one active, you can right click and set current. Okay, but right now the current model is this one. Okay, make sure run spec. Okay, I already press run spec. Static good. Net to gross NTG. Permeability along X perm X. Perm Y perm Z. Poro. No aquifer. Relative permeability good. PVT good. Initial good. Rock good. And then let's hope for the best. Initialize. Okay, let's hope for the best. No problem. Yes. All right. 55%. All right. Let's see. I think it's good news. Okay, I think this model is ready. So yeah, some problem. Maybe usually if you find too many problems, just try to close the model. Okay, and then open again. Maybe something better can happen. So here, after the the green button changes to red, it means that we are ready. And the initialization results are shown here. The most important is this one, the pore volume, this one. So 4,839 point something thousand reservoir meter cube. Okay, and then the free gas in place, mobile water in place, water in place, free oil in place, and others. Okay, so this model has been initialized. We achieve the virgin condition, okay, before production. This is the initial condition, virgin condition, or equilibrium condition, okay, prior to any production or well test or injection. So now we are ready to perform history matching, okay. As you can see in wells data, we already have production history and perforation history. Now we want to make sure that the model is right. So we perform history matching. Okay. But before that, okay, we can create template for the result. Okay. You can use predefined templates like this one, and you can monitor the progress of your matching. This is the predefined templates, or you can also make your own templates. But let's use this predefined templates first. Here we have production rates, liquid rate versus time, and we also have gas rate. This is the production totals, the cumulative. This is the historical versus calculated, matching, matching oil, matching presentation. So you can monitor the liquid rate, oil total, water cut, and oil rate. This is the matching gas, total, total presentation. This is the predefined templates, but you can also create your own template if you want. Like this one, add template. Okay, or you can exit and predefine templates again. Here we have, or let's check this one and then history matching. And then I will select this one. Now the model is run and we can monitor the progress of the history matching, and we can create our own templates. Okay, add template. Wells, I want to show the rates. Okay, for example, I want to show the oil rate and I want to show the oil rate H or historical. Okay, and also I can this one, so I only have this one, but I can change this one, template options, and as you can see, I only have one plot. That's because here I only have one. I can make this one for grids. If I click apply, I will have 4 plots. Okay, so I will use that. Click OK. This is oil rate versus oil rate calculated and oil rate historical. I change to this plot. Here I want to show the liquid rate calculated and liquid rate historical. Okay, here I want to know the water production rate and water historical. And here I want to plot the cumulative maybe totals. I want to see the cumulative liquid, for example. Okay, or yeah, liquid total and liquid total historical. Okay, by the way, the history matching has been done and you can see it is not match. You can see this red color is the calculated oil rate calculated by the model, whereas this dash line, if you see this index or legend, it is historical oil rate, and it's totally doesn't match. And this one, this blue line is actually calculated water rate, so it's still 0. If you check the table, the model gives me 0 for water, but actually in historical water rate, we have water rates, not 0. So of course, there is problem with water production prediction. But in field, we have perfect match. You see, this is the liquid rate calculated. This is the liquid rate historical. And we have perfect match. Why? Because if you see at wells data, strategies, global rules, or historical well count, I use liquid rate as control mode. So what does it mean? It means that tNavigator will lock the liquid rate and it will make the calculated liquid rate based on simulation perfectly matches with the historical. So that's what control mode means. That's why if you go to graphs, you see they are matched perfectly. And of course, if the rate is matched, the total also match. So if you go to the cumulative total, they are matched. But if you go to here and you want to plot the oil total and oil total, yeah, oil total historical and oil total, they don't match. Okay, they don't match. Here, they don't match. So what should I do? I will do the history matching. I will do some modifications. I can do, like for example, I can do assisted history matching, for example, the complex one, the advanced method, but I can do also manual modification. So if you see here, the model gives me 0 water rate. So it means that the model gives me or tells me that the water doesn't flow, whereas the oil flows quickly. So it means that I need to change the relative permeability. Okay, I need to change the relative permeability. So if you go to fluid properties, relative permeability, so here, yeah, you need to change it. Okay, so if I press, I want to make the water to flow earlier. Okay, So let's see if we can change it. Yeah, if we go to the relative permeability, this one. So I will try to change and follow this one. So I should use this one in the first place. So yeah, that's the thing I will do. Okay.